So before I tell you what I think Python is, tell me, what do you think Python is? Anyone have thoughts? Shout it out. Coding language. Great. Coding. What else?
Building blocks.
Building blocks. Yeah, like it helps you get somewhere. What else? What have you heard about Python? Is there anything that friends of yours have told you about? Like, you gotta do Python because it can do this. What have your friends told you?
It's a programming language like any other language, but it's much more readable and easier to program.
It's readable, it's easy to write, right? Easy to program.
My friend uses it to build economic models.
Oh, so cool. So one of her friends builds economic models, and if your friend's an economist or a student, right? Mm-hmm. What else do some of your friends do with Python that they told you about?
Visualization.
They build cryptocurrency algorithms? What?
They like to combine files.
Combine files, right? Merge and combine files. Here's the truth. You can do almost anything with Python. You can build, Python's built off C. It's actually built off the operating system for Windows and Linux computers. So you could build an operating system with Python. You can create visualizations with Python. You can merge files. You could create trading bots, machine learning algorithms. You could build a web application with Python. It's such a dynamic language. I'm not discounting R. I know Jacob loves R, and I think R is phenomenal. And I do agree you could or should consider learning both. In the beginning, pick one, stay with one. It's not worth going to both because why split your time in two languages when you can do one? If you're working for a company or a department that says we're an R shop, okay, go for R. And as Jacob mentioned, it's not too much more difficult to learn than Python. They're very, very similar in difficulty. But you can do anything with it. And today and tomorrow, we're going to focus specifically on how to program. Show of hands, who is this their first programming language ever? Like never coded, ever.
Oh, I mean
Exit. Yeah. Okay, so over half the class first code. For those whose hands didn't go up, what programming languages have you coded with before? R.
SPSS.
Doesn't count. SPSS. Although SPSS can code, it's not really code. But it's actually it's helpful that you.
Stata.
Stata's more code. Yeah. Stata's like MATLAB for sure. So R, Stata, Java. Okay, cool. C++. Okay. Any others? Well, you said MATLAB? Yeah. So if you come from MATLAB, you're gonna love Python. Python runs almost exactly like MATLAB. The syntax is a little different. So it'll be really easy for you, I'll just mention. For any of you who come from the C background, Python runs on it, so it's also pretty similar. Cool. Yeah, so that's a little bit on Python. Okay, so now we are going to, it looks like everyone's red stickies are down, so everyone has, oh no, one more sticky, but everyone else has Anaconda Navigator working. You should have this Jupyter Notebook up as well. If you don't, red sticky. We're going to make sure you get that. Okay. Next step is we're going to download some files. So let me open up the files I want us to work with to download. By the way, here I'm going to send you a link. So in our setup, we have this link. So I'm going to put this link right now on the Python section. So this is data to download. So if everyone can open that link and download the data. And the easy way to do that is Figshare is a site that you can host projects. There's a link here that says download all. So choose download all. Okay, so let's all download everything here. And then once that's downloaded, for purposes of our workshop, I would say create on your desktop a folder and just call it the name of the workshop, DC, like data carpentry, dash 2018 dash 01 dash 11 dash Rutgers. Right? You can call it something else if you want. Everyone's like, wow, this is so complicated. Well, you should always be specific and efficient, right? Or, I mean, I don't want you to just call it Python, because like that's not necessarily a better naming convention. But do that, and then take your zip folder and unzip it, and then go into it, and then create a new folder called data. Copy, put everything in the data folder, and put it in that folder. I did like super fast, so you guys are, obviously some of you are going to be taking some more time. But basically unzip it, create or rename the folder, rename it data, and put that in your master folder. So once you have that done, put a green sticky up so we know that you've downloaded the data and it's on your desktop in a folder. And if you can name the folder how I'm naming it, it's great, because then when I code, you know, you're going to be in parallel with my naming conventions, right? And you're not going to be like, what's going on? So that's actually how I named the folder. It's okay if you name it different, but it's a good habit to name everything for the rest of your life moving forward with either these hyphens or with underscores. So this is also moving into something called camel case. So like you should never, ever, ever name anything in your life again like this. Like that is not that readable. This is okay only for R. So I generally don't recommend the dots. Because in Python, dots actually call functions. So it will break in Python but work in R. I like the hyphens. I would say this is good, but the best is always to use underscore. So DC underscore 2018 underscore 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 for life. Like in the yearbook, if someone said don't change, they would say keep the underscores. So I totally think that you should do that, right? I don't crack many jokes, but I'm glad you guys thought that was funny. So I'm actually renaming my folder with underscores right now. And that's really good for two reasons. Number one, it's readable. It's easy to read. There's no breaking that will happen between languages. And two, when you code, we're going to go into a concept called tab autocomplete. The underscore helps you autocomplete and break between things very easy. And this is important because notice this folder is January 11th. So if you're doing reporting and you have many Excel files on the 11th, the 12th, the 13th, you want separate folders. So easy way to move between folders. Great. So that's high level on naming conventions.
What were you saying about underscores data?
Oh, no, the dots. So in Python, we're going to learn this, but dots are a shortcut method to call functions. And in R, it's not. So in R, if you name it like this, that's great. But then in Python, it might break and cause the code to do weird things. So it's just best not to use the dots for naming. Great. Okay, and again, green sticky up once you have the data downloaded. And it's on your desktop. And it's in a folder. I promise I will not croak here today. I'm going to be okay. Okay, now the magic starts. So because we are using Anaconda, your life is easy. You're not installing packages in the terminal. You're not doing very complicated things. Everything runs here. So it's going to be great. We've installed Anaconda. We've launched the Jupyter Notebook. So we're all good there. And now we are going to, I'm going to walk you through how the notebook works. So yours will look very similar with files, running, and clusters. Files is what's on your computer. So this is your directory. You will have different things here than my directory. Running will be if you have multiple terminals open on your computer, multiple notebooks working in your browser. So maybe you're doing many projects together, they're open. And clusters is if you were doing things on servers. Okay, you're uploading files if they're not on your computer. Your new files if you're creating new files. If you already have IPython files, which I may have one on my computer. I think I usually delete them all. No, I have one. They're just for your reference. So General Assembly, I have it, downloads, boom, just to show you. You won't have this. But like I have this, all Jupyter notebooks end in .ipynb. It's IPython notebook. Those are the files. So if you already have one on your computer, you can click it and then it just opens. So it's great. You can edit it, the bolding, the code, you know, all of that. So that's great. You won't have that yet, but that's just for your future reference. What we're going to start with is let's go to the folder where our data is, just as reference. So like you can click on desktop. On desktop, you have the folder, DC records, the data folder, and you can see everything here. You traditionally wouldn't open the CSV or open the JSON files, but I want to create my Jupyter notebook in this folder. I want to keep everything structured, organized together. So rather than just creating new notebook, if I do that, it's going to create on my desktop. I want to create in this folder. So I'm choosing to click on the folder we created, click on the data folder, and now I'm going to create a new notebook in that folder. Notice, because I also have R installed on my computer, I could create an R notebook. So as I mentioned, you can open Python, R, C, any language. But actually also show of hands, whose shows Python 2? Hopefully no one except me, because I teach workshops in both Python 2 and 3. Does everyone say Python 3? And does anyone say just Python? Okay, great. So everyone's showing Python 3. This side of the room, no one raised their hand, but it all said Python 3. Okay, great. So we're going to run in Python 3. Just to answer another question. So for a long time, Python ran on 2 and 3. Because the research community hates to update things. So they stayed in 2, and it's really tough. Like imagine you have hundreds of lines of code, or thousands of lines, or millions of lines. Too much to update. So they stayed on 2 forever. The developer community moved to 3. Generally, they do the same thing, except 3 has easier syntax. Actually, harder syntax, it has parentheses. But it works better, it's easier to read with the eyes. So that's why we moved to 3. Today, some people still use 2. None of you will hopefully ever use 2, because I'm training you with a new habit. Also, 3 weeks ago, NumPy, which is one of the quintessential packages in Python, officially said they are dropping support for Python 2. They're no longer updating it. And since NumPy stopped, everyone else is going to stop. So 3 is what you want to work with. It's going to be just more readable. So we're going to get you with good habits. So now, new notebook, you can click on Python 3. And when you click, you should have a new screen appear. So we can see a lot of things going on here. Kind of looks like a Word document, but different functions. File, edit, view, insert, cell, kernel, widgets. We'll go through those. But really, this is all you need. These are the shortcuts. You can save, right? So you save. It auto-saves every, I don't know how many seconds, every 10, 15 seconds, it's going to auto-save, so you shouldn't lose anything. You can add new lines. You can delete lines with cut. You can copy lines. You can push lines up or down. You can use play to run code, stop to pause code, refresh to go through all the code again. There's lots of other things, but those are the big bulk that are worth your time. Okay, before we start coding, any questions at all? Yes?
Can you access your whole PC using the Jupyter initial page? Like I see you have desktop, but you don't have the local hard drives.
Okay. So the Jupyter Notebook, what he's mentioning, which is great, is he's looking at my web browser. Localhost 888 means it's my computer, right? So as my computer, it's my desktop, it's this file. He's saying now, oh, can I access different files? In Python, we're going to learn a way to access files from my computer in working directory. But in general, we can't like change directory or move around in Jupyter Notebook. There is alternative things called IPython, which is outside the scope of these 2 days. But IPython you run in your terminal, and then you can do that. Or you can just run Python in your terminal. So there's many ways to work with Python, but this is the simplest one by far. So that's what we're going to work with. Great question. Okay, so let's start coding. Woo! Okay, so one of the best initial statements in Python is the print statement. Print lets you output to your screen, and it lets you debug broken code. So our first line is going to be print, and whenever we put stuff in print statement that is text, we use apostrophes. So print, hello world of ecology. We open with parentheses, we close with parentheses. That's Python 3 function. And if we want to run this now, we can just press the play button. And when we press the play button, notice that now we see output on our screen, hello world of ecology. So we said print it, and it has printed it. Our input, our standard in, is print hello world of ecology. Our output, standard out, is hello world of ecology. You can also do ShiftEnter, but that creates it as like a new line. What standard is Control-Enter typically processes the command as well. Yeah, so on Mac and PC, it should both be, I think, Control. We can try for PC if it's a different command. Okay, also notice, right, I could press the scissor. I deleted it. I can go edit, undo, and bring it back, right? So just like Word document, we can do some things. If I have multiple lines, say this one is print, goodbye world of ecology. Right? So now, Shift-Enter, or Control-Enter, I can move the code up or down. Right? So if you want to adjust it for your research, how it looks, I can run just this code by highlighting it. Okay, and we'll get into more nuances of Jupyter. Okay, but we're going to delete the goodbye world of ecology because we just started. So we've looked at the gallery of notebooks, and we noticed some interesting things. Let me pick one that someone put here. Oh my gosh, is there only 11 students here today? Kidding, guys. Make sure you please put one up. But we're going to look at Mallory's. This is cool. Traveling salesperson, how they move throughout the U.S. All this code. Love it. What do you notice here? There's bold things. There's blocked things. Not blockchain, just block indent. All these cool things. So why I'm showing that to you is we can use Markdown in Jupyter Notebook. Markdown means formatting. So if I were to type, well, I have to choose this as Markdown. So where did we do this? View. I forget where Markdown is on here. Code. Markdown. Amazing. Virtual high five. Okay, so you would switch to Markdown. You're not going to Markdown and code. It's Markdown or code. So we can type double ampersand, not ampersands, double hashtags, and then write something like, here is Markdown subtitle. And it looks like Markdown because it's not actual formatted, but with Shift-Enter, then it goes into effect. and we see the format. So your next question logically will be, well, what are all the formattings I can do here? So Python, Markdown. The one on GitHub is interesting. The github.io is even more interesting. No, that's not the one I want. It is... I had this link open the other day. I just want to share it with you guys so you have it. It is... Cool, this page. So I'm going to share this page with you on Etherpad. Right over here I'll do Python, Markdown, formatting. So, for example, you could do anything you want. Bullets, we can do number lists, block quotes, bold, big headings, smaller size, different size headings, mathematical equations. We could have them formatted and written out as if they were in Word documents. We can even use certain lines that create a table. We could do HTML. We can call on images and videos and GIFs. So this link I shared is an example of what you can do. It can get very advanced. The purpose of these 2 days is not to teach you Markdown, it's to teach you Python. But you know, the gallery of interesting notebooks show a lot of Markdown. So let me show you one more interesting thing with gallery of interesting notebooks. So let's pick another one that someone choose. Jacob, what did he pick? Something on calculus, of course. Wait, is this Jacob co-instructor?
Yeah.
Awesome. Of course, calculus. I love it. So this is like super. Is this your notebook, by the way?
Yeah.
Amazing. Even more awesome. So super cool. And he has some Markdown here. Bolds. Generally, most people don't get crazy with it. They just bold things, and the rest is all his code and the cool things he made. But let's say you really love this notebook, and you're like, man, I want to know how Jacob built this. So notice every notebook that you view has some things up here. Most of them not too important. Frequently asked questions, pull you to GitHub, but this is the download button. So we can download it. So let's all practice this together. So under the Etherpad, where it says Jacob Calculus with Python and Genie Index, click on his link. Hopefully we do not crash GitHub right now, because GitHub was down today from 10:20 to 10:43 a.m. So I was like freaking out this afternoon. I was like, who's hacking GitHub now? But let's all download this. So click, and it should download. They're very small files. It's literally just text. It doesn't download the output. It's just text. So they're very small files. Okay, now you're probably starting to get more tabs open like I am. So don't forget where your Jupyter tabs are. Notice from Jupyter you actually have 2 tabs open. You'll have your overall Jupyter and then the one we're working on. To the extent that under running, we see now, I have open, earlier the pandas one I opened from GA, so which we're not doing, and the untitled one. And so what I want you to do is under files, look for the file you just downloaded. So mine, the directories here, this is your directory. So you can go up by clicking on each folder, or just press the dot dot. So dot dot goes up, dot dot goes up, and so forth. And I downloaded to my downloads folder. You probably did too, or your desktop. Here's the Calc Genie file. I can just click it, and there we are. Now I have his file open. I can read this code. I can re-execute the code. I can see, look at this. This is all Markdown. I can double click on the Markdown and then see how he generated it. So notice that this is a table, but he literally generated just with some nice vertical and horizontal lines. So really cool. So if you find anything interesting, also notice here, L of X, EX, right? That looks formatted like it's like a function, right? And we can see that these certain symbols, this $sign, lets you format it as like an equation. So as you guys go through Gallery of Interesting Notebook, double click and then it views it, and ShiftEnter just turns it back into the output. So double click and then ShiftEnter. So as you come across interesting notebooks, you're like, wow, I wonder how they block this. Wow, how this image gets here. How they bold this. And you can learn more about Markdown. All right, so yes?
On a Mac, when you download from GitHub, does it sometimes just open the file? Is like there's something you have to do to actually save it?
Interesting. Where did it download to?
I don't think it downloaded. It just seemed to open in another tab.
Oh, did you open it straight from GitHub? Okay, so on here, where's his file? This is his file. So this link pulls you straight to GitHub. Did you by any chance accidentally click that? So notice here, there's the download one, and then to the right, to the left of it's GitHub. GitHub, you can view Jupyter Notebooks straight on GitHub. So we haven't talked about GitHub, and unfortunately we don't cover it today and tomorrow. But GitHub is a version control system. It's how you can manage changes to projects when you work with multiple people. It's the largest version control website out there for tracking projects and the data changes. So as you guys get more interested in data, you'll you should, I encourage you to host your projects on GitHub. And then for employers or departments you work on, you can share it. Now, GitHub is public by default. So if you are working with sensitive projects or sensitive files, you would need to create a private GitHub, which is not free. Students, I think you sometimes do get a free one for a year, or it's a discounted one. But private, you would have to create and pay for if you have sensitive data. Otherwise, everything's open to the world. So just be mindful if you're working with financial data, social security numbers, medical data, so forth, and privacy rights. Yeah? So this is my home screen right now, and I can go back up.
The top level.
Yeah, this is my high level.
Again, it goes back to the same question that you asked. Like, I can't access all my local hard drives here. So do you feel this restricts you only to save files in certain folders like desktop and downloads?
You're saying you can't access everything, or you can?
For example, if I store something in my D drive, I can't access it through this.
Oh, your D drive.
Yeah.
Oh, so if you're on a computer that has multiple hard drives, like an HDDC drive and an SSD D drive, keep it on the primary drive that your computer is running on. Otherwise, you have to switch over.
No, it's not those drives. I'm just saying like you can just access desktop and documents. You can't go to my computer through this.
So what you see here is based on your active running directory that you set as default. So for example, my active running directory is the David Yakubovich directory, and then in here is everything that I have, like GA stuff, machine learning stuff, the stupid folders I can never get rid of from Apple, like movies and music, you know, and so forth. Yes, and you can change that directory as well. We'd have to look up the exact code for you, but that's something you can look up. Yep. Great. Before I move into actually coding more, other thoughts, questions? Anna or Jacob, any insights or things you want to add?
If you want to do more with equations, I put a little cheat sheet in there. That's LaTeX. Everybody should know it. It's like the best.
Yeah, and so what Jacob means, he's like a mathematician by trade, and mathematicians love writing math tests. And math tests have equations that you want to be formatted beautifully. And I don't say right, LaTeX, is it how you say it, or Latex?
I mean, I say LaTeX
Yeah,
and Latex.
LaTeX, Latex, Latka, you know, it's basically, it's how you can write, and all of this, Latex is Markdown. So all of this can apply to Jupyter, and a lot of web pages are built on Markdown. So you can really get involved in it. Most people who write math tests before Microsoft Word got Equation Editor would use Latex. So you would actually build it and everything. And before printers were good, with Print Preview, you'd have to print it to see if it printed right and then keep reprinting to update. So it's changed a lot. But yeah, if you're doing a lot of math things, like you're trying to explain an algorithm in your research, you would use Latex to format that algorithm so people can understand like the math behind it. Great, and Jacob put that link here, equations and Latex cheat sheet. Cool.
What exactly is a Markdown?
So Markdown, that is actually this, right? So this is Markdown. It's not your code. It's all the formatting with the hashtag, with the dollar signs here, with these. So Markdown is formatting text to look pretty.
Oh,
That's all Markdown means.
bolding, underlining.
All that. And Latex is like the operating system that runs Markdown. You can think of it like that. Latex has been around since, I don't know, 60s, 70s, like long time. Yeah. Okay, anyway, the purpose is not to spend too much time on Markdown, but I wanted to introduce it to you, because if I don't, it always comes up. So I'd rather spend 20, 30 minutes on it so you guys get a sense. Cool. Other questions, thoughts, though, before moving into Pythonic language? Okay. And how are we doing on time, so I'm aware? In 15 minutes we'll take a coffee break. Into nuances in Python. What's our first one? So we can create variables. If we want a variable called text, I can say text equals, and then use quotes, data carpentry. So I'm now creating a new variable called text at which the value, the string data carpentry, is being stored. If I press Control or Shift Enter, notice the difference. Control Enter doesn't create new line. Shift Enter does create new line. So generally we're going to do Control Enter unless we want to output. So text is data carpentry. I've stored it in text. To call it to the screen, I could do just text, but it is more traditional in Python 3 to do print text. Another common question comes up, oh, can I do with one apostrophe or with two apostrophe? Yes, they're the same thing. There's no difference. But if you want to store a quote in text, like from an actual quote in a book, you would store it like this. The data carpentry string in quotes. And if we do that, then we have the quote. Or you may have not wanted to format it like that, because maybe you actually wanted the quote, so we'd format it like this. And then we get our quote. So that's the only reason you would ever use two quotes in Python. What's going on? Cool.
Oh, I just didn't know because the numbers are adding up more every time you did it. The lines
Oh yeah, so every time you run code, you're inputting new lines.
But you don't see them?
Only if you do Shift Enter and I type in a new one. I'm overwriting it. So by choice, I'm overwriting it. Yeah. Yep. Okay, what else can we do? So we just stored text. We could store a number. Say number is 42. And if I did Control Enter, we don't see it. If I do Shift Enter, I still don't see it. But Shift Enter lets me store it and then create a new line. I could print the number. And now we have the number 42. Another interesting thing you can do in Python, one hashtag outside of Markdown is a comment. So if I could say the below is the value of pi, and then I could say pi, we love underscores, pi underscore value is 3.1415. And if I do Shift Enter, still don't see anything, I could print pi value, and we get the pi value. But this is just a comment. So the hash means I'm not actually running it. When I run this code, the compiler or the machine is smart enough to say I'm just running the non-hashtag lines. There's two ways to do comments. One way is like this. which is very common for reading vertically, which I recommend. Another one which can be good for short comments is in the same line, the value of pi. So you could do that as well. You can't then end the comment and do something like this. You can't then put math there. So there's no like after a comment putting math or putting a function. It's either comment here or comment here. Cool.
Do you have to put a space between the equal sign?
No, you don't. So first off, on the comments, you don't have to do a space. Secondly, in the code, you don't have to do a space. I think it's more readable, so I like doing spaces. It's up to your preference. Great. Okay, so far we have seen one method called the print function. Functions are methods. That's the terminology we're going to use in Python. So we have the print method. Let's look at other methods. So we have stored now text as some text. So I could actually call the type method. Let me find the type that is the text. Let's see what this does for us. The type method tells you what is the classification of your variable. Is it a string? Is it is it an integer? Is it a float? There's many different properties. So all texts are always strings. If I said the type of number, we get an integer. 42 is an integer. If I create another one, let's say number 2 is 42.01, then we can find the type of number 2 and see that it's float. Float means there's a decimal attached. Great. Okay, any questions so far on while we're reviewing?
What did you
Yes.
use to get from number underscore 2 to float?
Oh, ShiftEnter. So ShiftEnter will both execute the line and run a new line. I could have just done Control-Enter and still get the output, but Control-Enter wouldn't create a new line. In general, my habit is to always do ShiftEnter because you're going to want to keep typing more code and doing more troubleshooting. But sometimes if you're experimenting with a line of code over and over, you'll do Control-Enter because you don't want to create like an extraneous row. Let me do something here. Great. Okay, so now we're going to learn mathematics. We can do mathematics never by hand again. We can do it in Python. So you can do something like 2 plus 2. It's 4. Amazing. We could do 6 star, so the star above 8. Right? So 6 star 7, 42. That's multiplication. We could do 2 star star 4. That means exponent. So 2 to the 4th, 16. We could do 13% sign 5. That's division or modular. So 13% 5 means the remainder is 3.
Yeah.
5 goes in twice, 3 is left over. Remainder. It only gives you the remainder. It doesn't give you the actual. Yeah. Okay, we can also run logical expressions. 3 is greater than 4. It tells us it's false. This is called Boolean. Boolean is logic. So they're true or false statements. So 3 greater than 4, false. 4 greater than 3, true. You can also run other ones. So we could do, so 3 is less than 4. We could do 3 is less than or less than equal to 4. So that's less than equal. We could do 3 is, if them, not equal to 4, apostrophe equal, right? 4 not equal to 4 is false. So this is exclamation mark. So exclamation mark in Python means not, opposite. So equal, not. And then we could run logic on logic. So what's the logic of true and true? True, right? If it's true and it's true, it's true. What if it's true or false? And for those of you who don't have a stats background, some of this may not fully compute. But we can recommend some stats material if you need. True or false in stats, or means either or, must be true. So if true is true or false is true is true, so therefore we get true. False and true, we get false. If true is true and false is true, but false is never true, we get false.
Could you just go again?
Oh, the last one I just said?
Yeah.
So for false and true means if false is true and true is true, then you get true. Otherwise you get false. And because false is always false, you can't get true. Okay, anyway, logic, like literally in college, there's like classes in logic. Like you could spend a whole semester in logic, so I'm not going to get too much into it. But this is to show you that you can run logical expressions in Python.
Is it case sensitive? False?
Yeah, so true and false is not true and false. It thinks you're calling a variable called true, a variable called false. So what we're seeing here, this is great. This is our first error. We haven't seen errors yet. So whenever you do something that is not correct according to Python, it gives you an error. This is a name error. It says true is not defined. First up, we never defined a variable called true. And second, Python doesn't recognize true as true. So it tells us in this line there's an error. And it tells you it's a naming error. And that it's tracing it to the line and what is specifically wrong. So Python attempts to tell you what's wrong so you can try to fix it. Okay, any questions so far before moving on to the next section? Okie doke. I also recommend you name your Jupyter file, so don't leave it untitled. So unless you're writing a book or a piece of art, so we could call this DC underscore 2018 underscore 01 underscore 11 underscore Rutgers underscore Python underscore day 1 day underscore 1. You could do it. I mean, it's like, why not? So rename. And then save. Auto-saved. So what I'm going to do is after this and tomorrow, like I'm going to save this Jupyter notebook and share the link with you guys. So, and we're going to share the data carpentry material as well. But yeah, I'm going to share it just in case you want to reference. Okay, it's 2:30. I'm going to give my voice a quick rest. You guys have a 15-minute body and coffee break, and we're glad to answer any questions in the meantime. So we'll see you back here at 2:45.